So I'm here to talk about ducks on a lake. I love my hat, but probably not good for the camera. Scaling data lakes to warehouse performance. So mentioned I'm from MotherDuck. I'm one of the co-founders. It is a company taking DuckDB to the cloud as a data warehouse and a data warehouse that's both used for internal BI and analytics, but also customer-facing applications. I have to jet back to our company team offsite after this. I left them for this. So feel free to reach out to me, though, on my social there or email just ryan@motherduck.com if you have any questions that I don't answer here today. All right. So I'm feeling pretty ducky today. Do you notice that? I'm looking pretty ducky. Someone at this conference who's speaking a little later today is a little less ducky. Andy is Andy sitting here? I don't know. But Andy, doesn't generally look very ducky. So he needs to be a little duckified. So let's fix that. Beautiful. That's like the only slide transition I've ever used in my life, and it worked really well. We fixed him. He's now appropriately duckified. Hopefully he doesn't take offense to that. All right. If you want a chance to be transformed in real life, there's a QR code and there's some postcards over at our sponsor table here that you can get a lot of free swag. And your own duck shirts. But today we're talking about lake houses and making them as easy as duck. So easy AD instead of maybe AF. All right. How many of you would, if we're separating our worlds into transactional database people and analytics database people, how many would say you're more on the transactional side? Okay. More on the analytics side? All right, some more analytics folks than transactional folks here. So my daughter is 9 years old. And so I'm going to call this next little section the Eras Tour. I want to show you how we got to having DuckLake. And a little bit about the evolution of analytics engines. A lot of you may be familiar with it, the folks that raised your hand secondly. But just a reminder, kind of the foundation which led to DuckLake. So the warehouse era. I just love LLMs today because you can generate 80s haircuts pretty easily. Starting in the late 1980s at IBM, and like many things at IBM, Xerox and other juggernauts, they didn't popularize data warehousing even though they created it. Bill Inman did that in the 90s, but their vision was grand. Build a place that you can store all of your original, it's called business data warehouse, all of your business data in one central place, and be able to easily retrieve it while sporting your amazing haircut. These projects were difficult, they were expensive. They were expensive to build, but most importantly, expensive to scale. Once you figured out how to put, your data in a small box and you wanted to scale up, it got exponentially more expensive. It took many years, many months into data, do the modeling of the data before they started to load it. And many of these projects ended up failing. Something like 80% of the time. If you ask our friend Claude the exact statistic, Claude says, "Would you like to give you a joke about data warehouses?" And of course I said yes. And this is the joke that it comes up with. It is a post-mortem on data warehouses, so we're already thinking they're dead. And at a particular company, 30 months, $8.7 million, resignation of 3 project managers, they sunset their data warehouse. Their initial goal was to provide a single source of truth, and they encountered a series of minor complications that rendered it largely unusable. How many of you been through that? Anyone? All right, some folks. This is why they considered it unusable, or why they think it failed. Their scope ambition surpassed NASA, and they wanted to have a single source of truth. ETL became ETL. Their daily job ran for 19 hours, and when they parallelized it, it ran for 22 hours. This is kind of why we build on top of DuckDB. They successfully loaded their January 1997 data by September 1998. And then their executive champion disappeared, went off for a yoga retreat in Sedona, and never came back. Have any of you had a colleague go off to Burning Man nowadays and never come back? That seems more likely now than the yoga retreat in Sedona, but same difference. As data infrastructure people, we have one job. We have a job to make infrastructure which makes people successful, which makes technology a superpower and not a burden. And we failed, obviously, in the data warehouse era. So it got a little bit better in the early 2000s. We had a lot of improvements to software, some great papers out of Google. Google File System, MapReduce, Bigtable, and these you put together and you created Hadoop, and all of a sudden we had something that could scale. And not only could it scale, but it could scale at a reasonable cost, especially when the cloud came along and offered us a separation of compute and storage. And allowed us to just scale the compute independently. So what happened with these from terms of how we store our data? Well, we decided we're no longer going to go through months or years of a process to model all of our data before we store it. We are just going to have this beautiful lake, and we're going to put all of our data in this beautiful lake, distributed storage, HDFS. We can query it with Hive. We can use Drill, which is sort of like an open source version of BigQuery. And all of our data is sitting there. It's awesome. Only it's awesome in a handful of ways, and then it's really horrible in another way. We're going to talk in the awesome first. First of all, you can store any of your data in there, structured, unstructured data. You get this proven scalability of distributed storage. We knew by then that distributed storage is fantastic. It's proven. It's also cost effective. The cloud storage was cheap, orders of magnitude less than storage in the on-premise world. And you can notice here that the pendulum is swinging. We decided, hey, we have a place to put all of our data. We don't need to think about the modeling in advance. We don't need to have years of projects. So thus, our project will succeed now instead of failing like the 80% of data warehouses. Only we created a mess. We created the data swamp, as they call it, or in this case, just a very ugly, ugly looking lake. We stored all of our data. We didn't worry about the format. We didn't worry about how we evolved the schema. It's very polluted. So that's really why the Lakehouse came along. And the Lakehouse said, all right, what happens if we can do ACID transactions in our data lake? And what happens if we can evolve our schema? What happens if all of a sudden we actually have a way to keep our data lake organized? Now, we still threw a bunch of stuff in it first, but at least we had a way to clean it up. We could clean up those swamps. So these open table formats gave us some really awesome capabilities here. And that was We have all of the standard features of a data warehouse like ACID transactions and data versioning, schema enforcement and evolution. We added on awesome things like time travel because, we all want to be able to time travel or run queries on last week's, last month's, last year's data. So these were all great things that this added. It also importantly allowed multiple engines to work with the data. So if you're considering, not from a data lake to a data lakehouse, but you're considering a data warehouse or a data lakehouse, people really wanted to avoid lock-in. They wanted to get data out of their data lake and be able to query it from any compute engine that they have. So one of the hard requirements that they had when building the Lakehouse formats is that we took all of the metadata and all of the data and stored it all in that blob storage. Stored it all without the usage of a traditional database. So there weren't external dependencies. Overall, this seems elegant enough. Why is it an issue? Here is what it looks like to do a very simple query against a single table. Imagine taking this and joining 3 or 4 tables together. You're having to do so many lookups of JSON files and Avro files in the case of Iceberg in order to just retrieve the list of files that you're then going to fetch to run your actual query. So we haven't even fetched any data yet, and we've already done, 15 different queries, 15 different HTTP requests here to different files. And this is really where the hidden complexity of the Lakehouse open table formats come in. You have multiple round trips. HTTP is not the fastest. It's gotten a lot better over the years with the latest specifications. But it's still, 15 or 20 requests for one table. Let's imagine you're doing 3 tables. Conservatively, that's probably 45 different HTTP requests before you even start making requests for the data. So this is really a killer and causes this performance bottleneck and reduces the performance of these systems. Now you can do all sorts of things around this. We'll talk about that here in a second to make them faster. You've all seen benchmarks and stuff from Databricks. There are ways to improve this, but at its core technology, that's what it is. You also have a small file problem if you do a lot of writes, a lot of transactions. Those writes produce even more metadata files and metadata files. So the problems can be solved using this thing, a catalog. Well, a modern day version of this, a catalog server. You store all the metadata in here, or at least kind of the high level metadata in here. This allows you to do multi-table transactions. It allows you to more quickly fetch the information about what files to query. It still generally will keep the metadata files on disk as well. So you have some element, some abstraction here, which improves knowing where all the data exists in an organization. And then, we have our friends Hannes and Mark. Hannes and Mark are the co-creators of DuckDB. They come from the Dutch National Computer Science Research Institute called CWI. And then they built out this company called DuckDB Labs and built DuckDB. Well, they care a lot about the aesthetics of systems. That's why DuckDB has become a lot popular or very popular, is because of the aesthetics. And they said, wait, the catalog is such an important part of the open table format ecosystem. yet it's not actually in the standards. It's a separate thing. It was a required add-on to the standards in order to make it operate at a reasonable performance and to make it easy to discover what data existed in an organization. So it's a separate product from Iceberg and Delta, called something like Polaris or Unity Catalog. And in turn, those actually used a database. So everyone who is using Iceberg or Delta really seriously will use a data catalog, and that uses a database. Why not consider all of this as part of a standard? Databases are designed for metadata. Let's use them to back the Lakehouse. So now it does violate one of the core principles that they use to create the open table formats. They said, hey, we do not want to use an extra system, an extra database, but things evolved and we're here to break the rules. How do we break the rules and make something better? Because these constraints don't make sense. And so, with DuckLake, the standalone card catalog is officially dead, as is the real card catalog, sadly. So we have ducks. We have ducks on a lake. Ducks on a lake have fun. It was really designed around these three principles: simplicity, scalability, speed. And we radically simplified how these things look by just having a database. Imagine that. It really is as simple as, instead of storing all the metadata on the file system or storing all the metadata in a catalog that stores it in a database that then accesses a file system that has more metadata, let's just use a database to start with. This can be any SQL database. Typically, it's referenced as Postgres. We actually use DuckDB for this in our current implementation, but probably are going to use more of a traditional transactional database in the long run. But it can be any SQL database that supports ACID transactions. You have that. You have your Parquet files, and so instead of having your metadata layer separate from your database with your catalog that stores some of the metadata, we just combine that all together into the same database. Simple. Scalable. Well, I mean, the process, basically it is just as scalable as any other data lake, because it is stored in object storage like S3, which is proven to handle a large volume of read and write transactions. You may wonder, doesn't introducing a transactional database server reduce scale in this operation? Generally, no. Companies have already gotten really good at running and operationalizing their transactional databases like Postgres. Almost every company already has one. They're used to it. They have the staff that understands it. B, Postgres is really designed to handle thousands of transactions per second. And if you think of metadata being 1/100,000th size of the data itself, in many cases, Postgres is pretty good. So you get scalability, you get speed. So instead of doing your query planning by retrieving 50 different metadata files and looking at those, you write one single SQL query, which again, Postgres is pretty good at. That tells you the files to read from. You still have to read those files from the object store, but it was a lot easier, a lot faster, sub-second time for query planning, regardless of the size of the overall data. So this is not my creation. You're missing the credit on the bottom right here, but someone created this, presumably with AI. DuckLake, you just have your SQL and your metadata for your metadata, Or you can use the other open table formats like Iceberg, and you have this manifest maze. So we've found a way to simplify, to scale, and to speed up uh, the traditional Lakehouse formats by providing this new open table format. So the question we often get is, well, what does this have to do? It's called DuckLake. Obviously, it's just for DuckDB, right? That's the assumption a lot of people have. Uh, yes, it is created by the same creators of DuckDB, the same people who like ducks way too much. But it is a open standard. The first reference implementation is built in DuckDB, but it is an open standard. DuckLake.select is the website. And due to its really simple architecture, it's designed to be easy for you all to implement in any system, very much unlike trying to implement a writer for Iceberg. So you might be like, why do we at MotherDuck care? So for any of you that know a little bit about MotherDuck, we created a data warehouse that's based off of DuckDB, a data warehouse that has our own storage format designed to be close to the compute for fast storage to achieve warehouse speeds. Why the heck would I be up here talking about this Lakehouse format? You know, the world seems to be kind of in one camp or in the other camp. Why would we be in both? Especially because we wrote a blog post called Big Data is Dead. This is from my co-founder. Aren't Lakehouse formats only for this big data? No. One of the foundational arguments in the blog post is that even if we have a ton of data in our tables, a ton of data in storage, our actual workload for analytics only touches a small amount of that data. People often only query the most recent week, the most frequent month, most recent quarter of data. So, yes, big data is dead in terms of your individual queries often don't touch big data, but that doesn't mean that you don't have big data, historical data. Even then, with that historical data, as you query it, you typically only touch a few columns. It's heavily compressed, and we build that infrastructure so that not much of the data needs to be read. So here's the challenges that DuckLake solves for us at MotherDuck. The first one I want to talk about is that historic data, right? So if we only touch, say, a few percentage of our actual data in any given week, any given month, we still now and then are told, oh crap, we messed something up in our business. We need to analyze the last 2 years of data. How do we do that? So your historic data you still want to keep around. What if we can have layered storage tiers? What if our data warehouse can store all of the most recent data that we need to heavily access that would be cached in most systems if we were doing a lakehouse, and keep it in that storage tier while also keeping the historic data in more of a lakehouse and have that relatively transparent to the users of the system. The same query engine processes both of the data regardless of where it's stored. Also, one of the challenges of building a data warehouse or columnar analytics databases in general and with the DuckDB engine and file format specifically is how do you get high throughput concurrent writes? DuckDB was originally created to handle your local data on your desktop. It's getting a lot better at sort of the high throughput scenarios here, but many types of workloads don't need that, but some do. Some folks have hundreds of Lambda jobs that are transforming and writing data into the data warehouse. What if each of those jobs can independently write to the object store? We can dramatically improve the write concurrency. Now, DuckLake also has something else special, which I think, again, my bottom of my slides cut off here, but DuckLake also has something else special called data inlining to enable the concurrent writing. Data inlining is basically saying that for analytics jobs, you want your data in a columnar format, but for loading the data, columnar formats are slower to write to, typically, depending on where your data is coming from. But if you have a large volume of quote unquote rows that you're inserting, that takes a lot of different operations on a columnar database. So what if we take this SQL database that we have for metadata, and we slightly abuse it to insert the data really quickly if we have a set of data that we want to stream in, in fast concurrent fashion. Postgres is really good at that. You can stream in the data into the metadata store, and it can periodically then flush that out over to the analytics database formats. Then how do we achieve system interoperability, right? If we have a data warehouse format, typically the data warehouse formats are not as accessible outside their engines than a Lakehouse format. DuckLake gives that to us. The modern data the modern data stack was a great unbundling of all of the data infrastructure. And now that it's unbundled, how do we make sure all of these different compute engines can read and write to that data? What do we have Spark jobs that we want to write along with using, our SQL queries? The last thing I'll say is around scale anxiety. So, we wrote that blog post saying big data is dead with a lot of intention. It is a bit of a hyperbole, we got to admit. But people naturally say, DuckDB, will it scale? It's this in-process analytics engine. How could it possibly scale to my warehouse or scale to be my Lakehouse? And so part of that is the messaging around things like the blog posts. Part of it is around DuckDB and the way that it's messaged and the way that it's designed. The reality is we've actually built a new type of distributed compute at MotherDuck. We don't call it that. We want it to be simple. But MotherDuck does scale through hypertenancy. So every user gets their own DuckDB instance. We have horizontal read scaling where we can, basically scale out the read operations to dozens of machines. And we have vertical scaling, all sorts of different ways that you can scale. And the idea with DuckLake is that makes that a lot better. People do need to feel good. They don't need to just hear that it scales. They need to see that it scales, and people see DuckLake and say, oh, it's built on object store. Okay, it scales. And that check mark is complete. So speed is really where DuckLake shines. It still may not be quite as performant on small reads as a traditional data warehouse. It may not get us our tens of milliseconds reads that you can get on a traditional warehouse that's built how we've done it with DuckDB. But it is a duck load better than the performance of other open table formats. So we continue as MotherDuck to offer our standard traditional data warehouse for those really sub-second, or tens of millisecond type queries. Very important for customer-facing analytics. This is a storage based off of the DuckDB format, but now we've augmented it to support DuckLake, and you can either bring your own bucket and directly access that bucket from MotherDuck as well as compute engines like Spark, or use a fully managed system where you can just say, create database, type DuckLake, and that's the end of it. So some of you might wonder, what about Iceberg? Isn't that the de facto standard? I would say that standards are meant to be challenged. We're here as innovators. Through competition, we make the industry better. DuckLake does build upon the innovations in these other Lakehouse formats. I don't like the negative mentality around it. I like to think of it as we're evolving. We're learning what's going on in the industry. We're evolving, and we're re-examining and challenging the constraints that we've seen. So lots of different features in DuckLake itself, but I do want to call out in particular like multi-table ACID transactions. One of the things that a lot of the table formats, whether they be the traditional Parquet or the Lakehouse formats built on top of Parquet, is they all think of this unit of a single table. How many of you really use just a single table at a time? I don't know about you, but in school, when I was in school, like it was all about denormalize everything. And yes, you go through cycles where you then normalize and then you denormalize, blah, blah, blah. But like, you know, we do think in multiple tables, and we want to run transactions in multiple tables to do views, you know, so we can update a view column while we update a column in the underlying data. You know, so DuckLake really does think of things in the database as a whole and not just table by table. So will DuckLake overtake Iceberg? I don't know. I do care that it is making things easier. And I do care that people can get up and running with DuckLake super, super quickly. And this was not my question, I promise. I am not MRO, whatever that is. But we also do want to support data engineers where they're at. Iceberg support was greatly enhanced and added write support for Iceberg in DuckDB 1.4, which was released 2 days ago. It was added the ability to both import and export data from your DuckLake in DuckLake 0.3 2 days ago. Sorry, that was yesterday. So we're continuing to invest in Iceberg while also saying, how do we make this better? So I'm going to stop quacking, and I think we have some seconds for some queries. All right. Anyone have any questions?
Yeah, thanks for presentation. So the interesting fact is I met the Professor Hassan, the DuckDB, the co-founder
Yep.
at a Databricks office. In my conversation with Professor Hassan, he mentioned that DuckDB was developed on vertical scaling, not the horizontal scaling. That is one thing. And when it is in vertical scaling, suppose scale up and scale down, that process in the dynamic process, how we are going to achieve it. And the DuckDB columnar database, is there any specific the partition methods or indexing when the tradition means the current Snowflake or any other the database is currently trending? So or ClickHouse, your competitor like the DuckDB competitor. So I just want to know more about the how the backend DuckDB is handling and Lakehouse architecture, the mother duck. We have the open table formats like the Apache Hudi, Iceberg, and the Delta tables. So all these three is going to support when we are doing the multiple updates. During that time, we are going to collect the manifesto files, how it is going to be interacting with the metadata file. So maybe multiple questions, but give me some answer.
I will try answering some of that. Feel free again to reach out or email Ryan at MotherDuck for the rest. Yeah, I mean, DuckDB was designed. I mean, frankly, DuckDB was initially designed because Hannes and Mark found it very frustrating that their fellow academics were using not real databases. They were using Python or R code in order to analyze their data. And so it started small. It started really small. And, DuckDB was designed for that use case. Scale up works great. DuckDB runs amazing on our MacBook Pros, even mine that's almost 4 years old. But as we do larger and larger workloads in sort of a warehouse environment, we've learned to scale up, vertically scale. We offer different instance sizes, but we've also learned that having an individual engine per person, per workload, per company is useful for a lot of different use cases to isolate the compute from one instance to another to maintain consistent performance, and also to just have different compute running your data analysis there. So I think you can scale it both horizontally and vertically. It really just comes down to what is your use case, like anything. And I'm trying to remember some of the other questions there, but why don't you just send me an email, Ryan at MotherDuck, and I can address some of the other questions that you have.
For the fully managed DuckLake instance, are you guys just also going to manage the Postgres as well for that?
Yeah, so like right now, we in the fully managed DuckLake, we actually use DuckDB as that transactional database. It's not as good as Postgres for that use case. So we will likely also be managing Postgres instead of DuckDB for that after we move towards more GA. I did remember one of the other questions was about partitioning. DuckDB itself doesn't do partitioning of data. That's actually one of the great advantages of using DuckLake is the file format supports partitioning. And eventually, I'm sure DuckDB will add that into their file format as well.
Add a couple more.
Yeah.
Do you know what the P99 is on top of DuckLake?
The P99 of what?
Just like querying like metadata, like how long, like I essentially want like a graph of like, if I have a query that's taking this much data, I can expect this kind of response time.
I don't have that for you. I will say that there's Hannes and Mark have done some performance testing with regards to the query planning component of it, which is the most expensive thing in the other Lakehouse formats, and can do a TPCH petabyte size query in sub a second for the query planning. Then you also have to fetch the data and analyze it, but like try doing that in another open table format. It's a lot more than less than a second. All right. Anything else?
Hi, do you have time for one last question?
Does it optimize for other formats other than Parquet? No, right now it is. DuckLake does store Parquet files. DuckDB itself does have Arrow support and does it do interop with Arrow, but DuckLake is a Parquet file specification.
Hi, Ryan. So I've read in some of the blogs and online documentation that you have that there are certain use cases for which DuckDB is not suitable. Like, for example, for enterprise data sets spanning to like terabytes and terabytes of like wide range of tables, the suitability is not there. Versus things like Databricks Unity Catalog or the wide range of use cases that it kind of solves. So how do you see these two ecosystems fitting together? Like, do you still think that DuckDB will continue to take this opinionated way of handling certain a certain type of use cases, or it'll over time evolve to like the entire spectrum of Lakehouse analytics, ETL, etc., etc.
I mean, I would take issue with the idea that it's not designed for terabytes of data. We have at least 2 or 3 terabytes of data in our internal data warehouse and use it every single day with people across the company querying it. I think it really just depends on how you architect that data, and some things need to be done a little bit differently with DuckDB. But for that, you get pretty awesome ergonomics in the end. But yes, I mean, like you said, right? So evolution is the important thing here with every technology. And we started off with DuckDB used just on a desktop by random scientists analyzing their few megabytes of files. And now we're at the point where, yes, multi-terabyte data warehouses can be analyzed with DuckDB. We see, we bill based off of consumption. So we see every time a new DuckDB release comes out and things get a lot more efficient. We have a brief dip in our amount of revenue, and then it goes back up, as we get more users. So these things are constantly getting much, much better, and we're working very closely with DuckDB Labs to kind of expand the abilities around concurrency and the abilities around parallel execution and parallel compression and decompression and all sorts of other things that you can watch. The awesome thing about DuckDB is it's just so active of a community. There's so much development going on, so many new releases. So yeah.
Thanks.
All right, thank you so much, Ryan. All right, we're going to take a quick break to grab drinks, restroom. Before we do that, I just want to remind everyone this is a small event by design, which means you can get to know people. So say hi to your neighbor, introduce yourself. Hope you have some interesting conversations, and we'll see you back in the seats in 15 minutes. Thanks.